A dilation is a transformation that will either make a figure larger or smaller. So because this transformation is changing the size of the shape, that means that it is changing the lengths of the segments. So this is the only transformation that is not in isometry. So to find the coordinates of a dilation, you're going to have a scale factor, and here the variable used for the scale factor is k. So to find the new points of a figure, you will take each coordinate, the x and the y, and multiply it by that scale factor k. So what we're going to do first is just look at finding the scale factor. So if we're finding the scale factor, we're going to put the distance to the new coordinate over the old coordinate. So we're going to go new over old. And the way that we can tell what's new and what's old is based on how it's named. So like if I look at this first diagram here, point C is the center of rotation. So this is the center of dilation. So the center of dilation. So it's like the dilation point, where the dilation is coming from. So the new segment, if I go from that center all the way out to the point of the image, so that will be A prime. So from C to A prime is going to be the new part, and from C to the original A is going to be the old part. And this is going to tell me the scale factor. So from C to the image of A is 7 units, and from C to the pre-image of A is 3 units. So if I look at these two figures, I can tell that the original triangle ABD is smaller than its image A prime, B prime, D prime. And so this is an enlargement. It got bigger as it dilated. So it went away from that center of dilation, and that made the figure get bigger. So with this scale factor, I can tell that this is an enlargement because the scale factor is greater than 1. So if the scale factor is bigger than 1, then that's going to make it an enlargement. The resulting figure is going to be larger than the original. So if I look at this second example I have here, again, we have point C, which is the center of our dilation, and we're going to go new over old. So here, I have that the distance from C to the point Q prime, this is a prime, I just can't see that prime, so that's Q prime, and then out here further is the pre-image of Q. So to figure out the scale factor here, I'm going to go from C to Q prime, and that had a distance of 3 units. So that's the new. So that's 3 units. And I'm going to put that over the old. So the old is from C to the pre-image of Q, which is this entire segment. So all I have is that from Q to Q prime is 1 unit, and from Q prime to C is 3 units. So altogether, that distance is going to be 4 units. So the scale factor here is 3/4. So if the scale factor is less than 1, so it's got to be a positive number, but if it's less than 1, so we'll say that the scale factor is between 0 and 1, then this is going to be a reduction. If we look at this quadrilateral here as our pre-image, so from Q to R to S, let me try to highlight this here. So from Q, R, S, T. So if I just lightly color this in, that's my pre-image. And then if I look at my image, the new shape, that's Q prime, R prime, S prime, T prime. And so this new figure is smaller than the original. So that's a reduction. So we can use this scale factor to help us find side lengths. So that scale factor is the ratio of all of those side lengths as well. So if we look here in example 2, we're going to identify the dilation as either a enlargement or a reduction. We'll find the scale factor, and then we'll find the value of the variables. So first, let's look at our pre-image, which has the normal letters A, B, E, and D. So my pre-image is out here around the edge. And then my image, as marked by the primes, A prime, B prime, E prime, and D prime, is interior. So if I look, the first thing I want to do is I want to identify the dilation. So if I look, my the original, the pre-image, is larger than the image. So since the image, the final product, is smaller than the original, this is a reduction. So if I'm identifying the dilation, I'm going to describe it as a reduction or an enlargement. This one is a reduction, it gets smaller. Next, I'm going to find the scale factor. So part 2 is to find the scale factor. So the scale factor is going to be new over old, and I can use any relationship between points. So if I look at the new figure, I see that this length from A prime to B prime is 10 units. So A prime, B prime is 10 units. And the original of that same side from A to B in the pre-image is 25. So to write this as the scale factor, I just want to reduce it. So 10 divided by 20, or 10 over 25. Both of those are divisible by 5. So to reduce it, I can divide both of those numbers by 5, and I get that the scale factor is 2/5. So this is a ratio of the new to the old. So I can kind of use this ratio to help me figure out these variables. So any set of variables should go by this scale factor. So if I'm going new to old, and I have that my scale factor is 2/5, so my scale factor is going to equal any ratio of sides. So if I'm looking next at side AD and A prime D prime, so the new is going to be A prime D prime, and the old is going to be AD. So if I think about my scale factor, so I'm on part 3 now, I'm finding the variables. So for my scale factor is 2/5, and A prime D prime has a measure of 8 units, and the old AD is X. So you might be able to see like the relationship here in like a multiplier that it would be going by. But another way that you can do this is by solving this proportion. So if I solve the proportion, I'm going to cross multiply. So this would say 2x equals 40. And then I can divide by 2, and I can say that x equals 20. All right, so now I have the value of x. So x is 20. So something I notice is that the side opposite of A prime D prime is B prime E prime, and it has that same length. So if A prime D prime and B prime E prime are both 8, then that means that this original side, BE, would have to have that same ratio, so it would also have to be 20. So x is 20 and y is 20. So by this same logic, since A prime B prime is 10, and I notice that D prime E prime is also 10, so those sides that are in the pre-image are going to have to be the same as well. So since AB is 25, the value of variable z is also going to be 25. So we can use that scale factor to help us find variables within these dilations as well. So the last thing we're going to do is we're going to look at some dilations as given by a scale factor and the original set of points. So I'm given the pre-image ordered pairs, So I'm going to plot those first. So I have 3, 5, and that is point P. And then point Q is at 4, 0. And point R is at 1, 1. So this is my pre-image. So I plot those 3 points and I draw that triangle. So the rule for a dilation is that you take the scale factor and you multiply it by the x value and you multiply it by the y value. So both parts of the ordered pair get multiplied by that scale factor. So if I'm looking and my scale factor is 2, one thing I know is that this is going to be an enlargement because that scale factor is greater than 1. So if I want to look at my ordered pairs now, so my center of dilation is the origin, so I can use this rule. And my scale factor is 2, so I'm just going to multiply both parts of that ordered pair by 2. So it's going to be 2 times 3, which is 6, and 2 times 5, which is 10. So P prime, the image of P, is going to be at 6, 10. So I just count that out and plot P prime. Point Q, the image of Q, I'm going to multiply both parts of that ordered pair by 2. So times 2 times 2. 4 times 2 is 8. And 0 times 2 is 0. So the new point Q is going to be at 8, 0. So this will be the image of Q, Q prime. And then for R, I'm going to multiply both of those by the scale factor of 2. And so the image of R will be at 2, 2. So I'm going to plot that. So one thing to notice is that when you do a dilation, it does move around the coordinate plane a little bit. So it's all depending on what the relationship is between those points and the center of dilation. So it will move a little bit sometimes. And so it goes out from this center of dilation to where those new points are. So it creates kind of a figure like those that we were looking at in the beginning. So I've dilated it. The result is a larger image because my scale factor was greater than 1. And you can see that it shifted it a little bit in the coordinate plane as well. All right, so let's look at this next one. So first I'm going to graph my pre-image. This has 4 ordered pairs, so it'll be a quadrilateral. So point J is at negative 5, 3. So I'm just going to plot it and label it. Point K is at 2, 3. Point L is at 2, negative 3. And point M is at negative 5, negative 3. So this appears to be a rectangle. All right, and with this one, my scale factor is 1/2. So since my scale factor is less than 1, this is going to be a reduction. The resulting figure should be smaller than the original. So I'm going to take this scale factor and I'm going to multiply it by each of these sets of points. So some of these points are going to be on decimals or like halfway marks. So I just take each one and I multiply it by 1/2. So if I take point J and I dilate it by a scale factor of 1/2, negative 5 times 1/2 is negative 5 over 2, or you can write that as a decimal or a fraction. So negative 5/2 is the same as negative 2.5. That's a little bit easier to graph when we're thinking about it. And then 3 times 1/2 is 1.5, or 1.5. So the image of point J is going to be at negative 2.5, and then it's going to go up 1.5. So it's going to be like right in the middle of this box right here. That's the image of J. So to find the image of K, I'm going to multiply each of those parts of the ordered pair by 1/2. So 2 times 1/2 is 1. 3 times 1/2 is 1.5. So half of 3 is 1.5. All right, so the image of point K is going to be at 1, 1.5. Next, I'm going to transform L. I'm going to dilate it. So I'm going to multiply each ordered pair by 1/2. 2 times 1/2, or half of 2, is 1. Negative 3 times 1/2, or half of negative 3, is negative 1.5. So point L is now at 1, negative 1.5. And then finally, I'm transforming point M. So I multiply both of those by 1/2. So negative 5 times 1/2 is going to be at negative 2.5. And negative 3 times 1/2 will be at negative 1.5. All right, so I got real close to the edge here, but that's a negative 1.5. All right, so negative 2.5 and then negative 1.5 right in the middle of that box because both had decimals in it. All right, so once I get that, I'm just going to connect those sides. And the image, the new rectangle, is smaller than the original. And I knew that that was going to happen because my scale factor was less than 1, so that is a reduction. So when it's less than 1, your new figure should be smaller than the original. When it's greater than 1, it should be larger than the